All right, this is problem 18 from section 9.7. 9.7 is all about special right triangles. You know that's going to come into play somewhere in this problem. So the problem says one of the angles of a rhombus has a measure of 120 degrees. If the perimeter of the rhombus is 24, find the length of each diagonal. So we have to know some properties of a rhombus. The first property, if the perimeter is 24, which this says, we know all the sides have to be 6. There are 4 sides, all congruent, thus making all the sides 6. So there's one of the things I know. Okay. You'll also know that the diagonals bisect the angles at each vertex. So whichever vertex has an angle that equals 120, you know that angle is cut in half, making 2 angles that are 60. Okay, so let me make this angle here 120. Well, if that's 120, you know that each of these angles has to be 60. And you know if each of these angles are 60, then these triangles are all 30, 60, 90. And that comes in, and another property comes into play, and that is the diagonals of a rhombus are perpendicular bisectors of each other. So, if this blue triangle is a 30, 60, 90 triangle with the hypotenuse 6, because basically if I pull this thing out, you can see, make it a little bit smaller, what I have is sides of 6, 30, 60, 90, this angle is 60. Okay, and I know that that makes the hypotenuse, or the short leg, if the hypotenuse is 6, the short leg is half that, and then the long leg is root 3 times the short leg. Okay, so this side is 3, this side is 3, this side is 3 root 3, this side is 3 root 3. So the diagonals, one diagonal equals 3 plus 3 or 6. The other diagonal, in this case the horizontal diagonal, equals 3 root 3 plus 3 root 3. Which is 6 root 3. So each diagonal has that as the length. Again, that is a very good problem. Brings into play a lot of the properties of a rhombus, also the properties of a 30, 60, 90 special right triangle. Okay. The second question I wanted to go over from section 9.7 was number 25. I thought this question was a good one because it is a little bit tricky. The question says ABCD is a trapezoid where DC and AB are parallel. That's not a typical trapezoid that we're used to seeing, so that's why I thought this one was a little bit tricky. But AB and AD are both 4, and that's labeled in the picture. And it says angle A is 60 and angle C is 45, both also labeled in the picture. The question wants us to find DC, and then also wants us to find BC. Well, what we need to do here before we start is put in a couple altitudes. Okay, these weren't in the picture, but I know that I'm going to need these to be able to do this problem. Okay, I'm also going to back up these 4s a little bit so that we can see better what we're working with. So this whole side is 4, we know that. But I also know, looking at this triangle, this is a 30, 60, 90 triangle. I made that an altitude. Again, the triangle I'm looking at is this one. I'll outline it in red so it's easier to see. But I know that the altitude is the long leg because it's opposite what would be the 30 right here. And then this side would be the short leg. So the short leg would be 2. The altitude, or the long leg, would be 2 root 3. Okay, if this is 2, then this piece here has to be 2 because that whole side is 4. Okay, so we haven't found either of the things we're looking for yet, but we're getting there. Okay, if I know this is 2 and I drop both of these altitudes, I know this is 2. So part of BC is 2. Okay, so I got that. You also know since this part here is 2 root 3, so is that part. Okay, so now this blue, I'm going to outline this one in blue. This is a blue triangle that is a 45, 45, 90 with one of the legs equal to 2 root 3. Well, that means the other leg is 2 root 3. And the hypotenuse, let's do a little bit of work, is 2 root 3 times root 2, or 2 root 6. So my answers for this problem are DC is equal to that whole thing, which is 2 plus 2 root 3, and then BC we just found is 2 root 6. So that's a good question. It brings into play 30, 60, 90, 45, 45, 90, properties of a trapezoid, all those things in that one problem. And it's a good one. If you had trouble with it, hopefully this helps you. That was numbers 18 and 25 from section 9.7.